Hello, everybody. Thank you for having me here. My name is Shrikanth Shankar. I'm a Director of Engineering at the Analytics Platforms and Apps team at LinkedIn. And I'm going to be talking a little bit about our experience scaling reporting and analytics at LinkedIn. Just a little bit about me. I've been at LinkedIn for a little over 2 years. Before that, I spent 3.5 years at a company called Qubole, which is a big data as a service company. And before that, I spent a long time at Oracle doing databases and BI. I spent pretty much all my career working with data in some shape or form. And so, this is something that's obviously very close to my heart. So with that, I think let's just get started. So this talk, even though I've talked about reporting and analytics, I'm going to focus very heavily on metrics. LinkedIn is a very data-driven culture. It's a culture where we believe that it's not enough to have instincts about things. I mean, instincts are important, but those instincts need to be backed by data. If you're going to make a decision, then you should have sound data that backs that decision. And that's how we drive a lot of the decision-making within the company. If you want to make a data-driven decision, then you need to start measuring and monitoring all your stuff. And metrics and how we compute and serve them is at the heart of a lot of our reporting and analytics, right? So whether it's experimentation, whether it's the executive dashboards that we show our execs, whether it's deep dives that people do to understand how various consumers are actually using our products, and even the metrics that we show our customers, right? Like ad dashboards or even end users about how many times someone has viewed your profile. All of those are metrics. So metrics are at the core of a lot of what we do at LinkedIn. When we started this journey, circa 2014, there were a lot of platforms at LinkedIn that did metrics. And it's probably a little generous to call them platforms. People just came in, wrote their own metric stuff, wrote their own data pipelines, computed metrics, and served them up. So we had an experimentation team. They had their own metrics platform. The product teams, which were measuring metrics, which were measuring how the products were doing, had their own set of metrics running somewhere else. Marketing has its own. Executive dashboards were powered by a different set of pipelines. And there were people who were computing metrics on their own laptops and desktops, and then using it to serve those numbers up across the company. Why is this a problem? Numbers don't match, right? You have your primary data, your tracking data, your databases, all of this. That's exactly the same for everybody. But each app has its own logic. Everybody, when they write a metric, they compute things slightly differently. And even worse, these things drift over time, right? Somebody changes something about tracking. Hey, page views should be counted not 1 second after the page is loaded, but 3 seconds after the page is loaded, or 5 seconds, right? And everybody had their own definition of this, which means that you'd go to app 1 and you'd say 100 page views. You'd go to app 2 and you'd see 95 page views or 80 page views. And this is bad. So case in point, your experimentation shows, hey, page views went down when you ramped an experiment. Okay. Why did they go down? Let's go see if there was a segment of users who didn't like this particular experiment. So you go to the reporting dashboard, and the reporting dashboard where you're trying to do these deep dives says, no, wait, page views went up. How do you actually rationalize these two numbers, right? So there was a problem with the fact that the numbers don't match up across these various apps that we had. There was an engineering cost. Everybody is running these pipelines on their own. It's taking up resources on the cluster. And that costs resources both in terms of human, people are sitting around watching these pipelines, and in terms of cluster resources. Why would you compute the same thing 5 different ways? And each of these systems is becoming a closed system, right? There was It had its own data, it had its own knowledge about how a metric was computed, and this was off in a silo somewhere. The rest of the world didn't actually know about it. This was bad, right? So about 2015, we said we needed to do something better about this. We wanted to provide a trusted repository of metrics and a self-serve platform for managing this life cycle. And you can see what we really wanted to do was have one way of computing those metrics, and then once the metrics were computed, sort of surface them in all these different apps that people wanted to view them in. And here were sort of some of the goals that we set ourselves when we started on this journey. We wanted to have the same metrics in all our applications, whether it was reporting, whether it was experimentation, whether it was anomaly detection, whether it was on the site, pickup, whether it was for doing deep dives. No matter what application you pick, you should have the same number. You should have a single source of truth. You wanted to have the same metadata. You wanted to have similar definitions of all the various kind of dimensions. You didn't want duplication. You didn't want two people writing similar but not same definition for the same metric. You wanted a single logic for the various kinds of metrics that you wanted to compute. People want to compute the same metrics at various grains. I want a daily version of page views, I want an hourly version of it, and I want a real-time version of it. Can I keep the logic the same? And when we started this project, our goal was explicitly that we'd have like one source of truth, one source of logic for all of this. And really provide metrics as a service to the rest of the company, right? So that people don't have to go off and create their own platforms and maintain their own pipelines and deal with all of this complexity. And so that's what we built. We started building this thing that we called the Unified Metrics Platform, and the idea was we'd converge around this one platform and put all our eggs in that basket. So in 2015, we launched the first version of the product. So I've spent a few minutes talking about sort of the problems we set out to solve. For the next 10, 15, next part of the talk, what I'll do is I'll talk about how this platform evolved over the last 3 calendar years, but 2 real years, right? And then sort of go into some of the technology we built and what we learned from this process. So in 2015, what we did was we took the platform that the experimentation team had built for computing metrics, and we sort of started modifying it. We just took their code initially. We had a central source code repo in which all the metric logic was stored. We allowed all the user logic to be defined in PIG, but a lot of the definition of metrics, a lot of other things were actually pushed into config. And we set up the ACLs on the source code repo so that if you checked something in, it got reviewed by a central team. So you couldn't just check things in willy-nilly. We provided a templatized experience for many of the common patterns. So if you compute metrics, you often need to do cubing because you wanted to, say, count uniques across a bunch of dimensions. You don't have a serving platform that can compute those efficiently at runtime, so you might choose to pre-compute that. You might want to have a way of computing window metrics, which is, hey, how many email clicks? I sent out an email today, like how many clicks did I get in the next 7 days, right? Like, and writing pig code or Hive code for that is non-trivial. So we templatized that and said, hey, just define this as a window metric. We'll take care of the logic for you. How do you do backfills? We templatized that. Self-healing, these flows fail all the time. And we made it really simple so that even if the flow failed, we'd sort of automatically recover and people didn't have to get involved. We had a single team that ran the operations, so we were responsible for providing the metrics for the whole company. And then we supported 2 important downstream applications. And this was a very big difference in culture. The old culture was, hey, I build an application, you define your metric, and the application pulls the metrics in. We sort of flipped it around and said, no, UMP is the center. So you come in, you define your metrics, and we'll push the metrics to all the downstream apps. And it'll be our burden to go integrate with each of these applications that needs to get built around metrics. We picked 2. We were building a new dashboarding tool called Raptor and our experimentation platform, which is where we had started this journey from. And we only supported daily metrics because that's effectively what we had at that point. We launched the platform in August of 2015, and in 5 months, we had about 1,100 metrics. So why did that happen? What worked? What did we learn, right? We had a huge product launch that came up in 2015. LinkedIn did this thing called Voyager, which was our new mobile app. We sort of completely redid our mobile app. Because it was a new app, all the metrics had to kind of get redefined a second time. The data scientists who were working with the product team agreed that, look, it would be nice to have a single definition of these metrics that they could use in multiple apps. So there were these early adopters and champions who worked with us. There was a lot of executive pressure on the product, right? People wanted this thing to succeed. And so correctness of data was a big issue. Nobody wanted to go and tell Jeff Weiner that, hey, you know, I told you that to ramp this feature because the metrics went up. No, actually, the metric didn't go up. I made a mistake. I had written the logic badly, or the metric didn't run properly that day. No one wanted to take ownership for that. They really wanted to hand it over to an engineering team that was willing to do that. People were watching these metrics every morning, which means someone had to own the SLA. Someone had to make sure the data showed up on time. And so there was an appetite to give this over to a centralized team. The new dashboarding tool we built decided that UMP was the only platform it would consume from, and that meant that that was the only way to get your data was to onboard onto UMP. A couple of very small things that we had assumed were not that big of a deal, like backfill support and things like that, turned out to be huge winners. We use Azkaban as our scheduler, and Azkaban didn't really have first-class support for things like this. And this proved to be a huge winner. So this was 2015. We launched the product. Neptune was Voyager was a very successful launch. People really enjoyed using the product, and so we had to sort of build on that momentum, right? So in 2016, we focused very heavily on a bunch of things. The first of which was usability. We had tailored our metric platform around people who were very technically savvy, and we wanted to sort of make it easier for people to use it across the company. So we did things like we simplified onboarding, we added support for new languages, etc. The second thing we did, and this was huge, was we supported intraday metrics. Remember how I said that earlier we started our journey with only supporting daily metrics, so you could only get daily page views, etc. But a lot of people wanted to say, hey, give me hourly metrics, right? So give me the metrics at an hour grain, and don't make me wait for 36 hours before I get the metric. So it's midnight, I don't want to wait till 7 a.m. To get the metric. Give it to me earlier. Give me the hourly numbers within an hour or so. So we supported hourly metrics, but we did it in a very different fashion. We said that you don't have to go rewrite your code. You just flip a config, you say, in addition to daily, I want hourly metrics, and we'll give you those numbers. Along with the experimentation team, we also did we also added support for experiments within 4. So the idea was that if you ramped an experiment, within 4 hours, you'd start finding out how the experiment actually was doing. And this was a big deal. This used to take us, I've put 3 days in the slides, but it was more like 5 days. So the thing was, by the time you ramp an experiment, it would take you 4 days to find out really how that experiment was affecting people because of things like statistical significance and so on. We improved the stability of the platform a lot. And we started automating a bunch of things that the team was doing manually. So one big example of that was people used to review the code and say, hey, is this a duplicate metric? Is this something someone's onboarded? We started building tools so that humans didn't have to do that. We supported more downstream applications. We supported Teradata, which we use pretty heavily as a data warehouse and /data mart. We added support for anomaly detection, which is a big win. So especially with intraday metrics, you'd start getting alerts if your metrics dipped very dramatically. And that was something a lot of people were interested in. And we added production support, which meant that you could take the same metric that you were using for internal reporting and show it on the site. So you were calculating ads revenue for LinkedIn. You could take ads revenue, segment it by company, and that would be ad spend that you could then show that particular company and say, hey, this is how much you spent in the last hour. And we quadrupled the number of metrics over 2016. So what worked? Neptune. We did another large product launch in 2016. We sort of revamped our web interface. And the experimentation platform, Excelenti, was key to this launch, right? So everybody like I said at the start, we're a data-driven company. We like to be we like to look at the results of experiments before we actually ramp something. And Excelenti was the only way we were making product decisions, and UMP was the only way you could get metrics into experimentation, so of course everybody started using it. All the work we did on onboarding and stability paid off. We internally measure the NPS of all of our products, even though they're internal products, and we went from -18 to 32, which is sort of the biggest jump I've seen of any product. And all these data scientists who had used it for pockets had started moving around and said, hey, this platform really works. Let's start using it as I move across the company. The platform kept up with scale. We quadrupled the number of metrics. We still continued working. Nothing really broke. And the idea of a single source of truth, the idea that you define this one metric and have it available across a wide variety of places, really started resonating within the company. And the last piece that I wanted to call out, I forgot to call this out when I was talking about 2015, was exec support, right? The people at LinkedIn, our executives, really care about not just not just the results, but of how we achieve them. They really care that there's craftsmanship around things in data and so on. And the idea of having the centralized platform really resonated with them. We got an enormous amount of executive support for this thing. So that was 2016. Now let's come to 2017. So what did we do next? Remember, 2015 was daily metrics, 2016 was hourly metrics, 2017 was the obvious next step, which was real-time metrics. And so the idea was the same. You have a single definition. How do you code generate real-time metrics from that? And so we built some infrastructure that I'm going to talk about more a little bit later, where you could just define the logic once, and we would define a real-time flow as well as the batch flow from that same logic. You just had to add a config that said real-time. 2015, we centralized code reviews. In 2017, we decentralized them. We had scaled so much that there was no way that a single team could actually keep up with reviewing the code for metrics across the entire company. But before we decentralized it, what we had done is we had spent the 18 months building tools so that people didn't have to do things that the tools could do. We built out a very sophisticated data pipeline monitoring that we call Where is my data? I'm going to talk for a little bit about it a little later. We supported more downstream applications, Presto, and defining things in Spark. We expanded our horizon beyond just metrics. We realized that we were part of the analytics ecosystem. Metrics are just one component of that. For those of you who are familiar with BI, in addition to metrics, you'll have facts, you have aggregates, you have dimensions. And you need all these characteristics that we talked about, having a single source of truth, having single logic that works across multiple execution engines. We wanted all of that to work exactly the same way for these other concepts. And so we expanded the platform to support all of this. We added code analysis, and then we started going beyond our original customer base, which is engineering and analytics. We started talking to people in marketing, people in sales about how they define their metrics and whether they could start adopting UMP. And this was the growth in the first 6 months of 2017. Again, a nice little bump there towards the end. And so what's worked so far this year, we became the de facto platform. A lot of people now don't even think about, hey, how do I compute a metric? They just come straight to UMP. We became the de jure platform because executives started saying, hey, I'm looking at this number, is it from UMP? Because I'm not going to trust it otherwise. I really want, right? So we got pressure from both sides. The product innovations we were doing sort of kept pace with user requests. The team was able to do that. Stabilities and SLA, which was a big fact of how people measure the impact of any platform, kept pace largely, right? We had large outages. When you grow this fast, this quickly, of course things will break, but by and large, this thing has worked, and this thing has scaled across a number of dimensions. And like I said, executive support. We continued to have people who really believed in what we were doing and our mission and our vision, and sort of said, look, this is the right thing, drive this across the company. And so putting it together, this is sort of a little bit of a journey of how the UMP metrics have grown over the last 24 months, 3 calendar years, right? That's only one dimension by which you can measure growth. Another dimension is how many people have onboarded metrics. You see a nice linear trend. How many inputs you scan, you again see a nice linear trend. So effectively, across all these dimensions, we've been sort of growing at a pretty fast clip. So I've talked a little bit about our journey, right? I talked a little bit of the problems we set out to solve. I talked about how we've actually saw, how this journey's evolved. And I want to talk a little bit maybe about some of the innovations that actually made this possible. At the start of the talk, one of the things I had said was something we had really wanted to do was this write once. You define a metric once, and you should have the ability to use it at various time grains. You need the daily, the hourly, the intraday. So in 2016, when we built the intraday platform, we held ourselves to that standard. We said, look, we won't force all our users, and it would have been impossible. We had 100+ pick scripts at that time. We have a 500 now. We can't go tell them, hey, go change all your pick scripts to work in an hourly mode, right? Just because we want hourly metrics doesn't mean the people who define them have the time to do it. How do we minimize the change footprint across the scale? Especially we were launching a new product. A lot of people wanted to see these metrics on an hourly grain. What we had done right when we launched the product originally was we had separated the user logic from the configuration about what data you scan, what's the range of the data you scan, what's the aggregation grain, is it daily and hourly. They were all sitting in a config file. And because of that, it was the platform that was generating a bunch of the code that decided whether to generate daily metrics and hourly metrics. So we had to do a lot of work on the platform side, but the users had to do almost nothing. Once someone decided that they wanted an intraday metric, they'd just go flip a config. They'd just say daily and intraday, and they'd start getting intraday metrics available for them pretty much seamlessly. There was a caveat to that. We still continued using Hadoop and MapReduce and Pig to run the scripts. We just ran them, instead of running them once a day, we ran them 24 times a day. And that was something we ran into in 2017, right? So we've done daily, we've done intraday. The next frontier is real-time. How do we get real-time metrics? This was especially important because we wanted to power product metrics, right? We wanted to say, hey, on the site, if you're looking at advertising spend, that number must come from UMP. It must have the same governance and same truth that our internal reporting has. So we said, how do we generate real-time? And the people who are advertisers aren't going to wait for 2 hours to figure out how much money they've spent on the site. They want those numbers in real time. The second thing we realized was that, look, Hadoop is not the only platform. LinkedIn runs Samza in your real-time metrics. We had started using Presto pretty heavily, so people were doing on-demand computation, which is ad hoc analysis against these metrics, and they wanted things that weren't really possible. We didn't want to go materialize everything all the time, right? And one of your observations had been that the UMP metric logic shouldn't be opaque to the platform. It's something that there's a lot of optimizations you can do. You know, if this script is reading table A and this other script is reading table A, why should they read that same table twice? Can you do an optimization where you read the table once and then each script goes off and does the remaining piece of its logic? That's what, if you were in the database community, you'd call multi-query optimization. We call it shared workload optimization. So things like that are only possible to do if you can actually introspect the logic and understand what we're doing. So what we did is, instead of saying, okay, we're going to standardize on a language and then compile that language down, we decided to standardize on an intermediate representation. And we use Apache Calcite as this intermediate representation. So what we can now do is, if you write your logic in Pig and you write it in Hive, we haven't yet got it working with Spark, but we'll probably do it over the next couple of months. We can take that logic that's defined in Pig or in Hive, compile it down to Apache Calcite, do a bunch of plan analysis, validation, things like that, and then generate logic for various platforms. So we can take that Calcite thing and then generate Hive. We can generate a Spark code from it. We can generate Presto code from it. We can generate Samza code from it, right? So we have the ability to go from multiple languages to multiple languages through this one central intermediate representation. And that intermediate representation is what we'll do all our optimizations on, what we'll do all our validations on. And this is something we actually have working right now, is we have taken a bunch of Pig scripts that our users wrote, compiled them down to Calcite, and then we've generated Samza code and deployed it in production. We also run the daily metrics. We still continue to run the daily metrics for various reasons, like optimization reasons. We can generate more dimensions in the daily metrics rather than the real-time pipeline. There's all these issues around when data arrives and completeness checks that the batch world is better for. And so we truly have this ability to do Lambda in a box. So this was, like I said, one of the many innovations that we made as part of the platform. A second one that we did is this thing that we called "Where is my data?" For all those of you who run data pipelines, I'm sure this is a question that you get asked all the time, right? There's these complex steps. Your data gets generated somewhere. It goes through Kafka. It lands on Hadoop. Pipeline 1 runs, then pipeline 2 runs, then pipeline 3 runs, and then finally it shows up on some dashboard somewhere. And there's somebody at the other end of that dashboard hitting refresh saying, hey, where's my data? And at LinkedIn, when people ask, where's my data, they usually ask the UMP team, hey, where's my data? Because most of those people are looking at metrics, and those metrics are usually the responsibility of the UMP team. And then the UMP team would then turn around and try to chase these pipelines across, trace this data across all these different pipelines and say, oh, it failed for this. And we got tired of doing this. And in our spirit of saying, hey, let's start whatever humans can do, let's see if we can automate it, we decided to build this thing called WIMDI. And the idea was that we would track this operational lineage so that if you're producing data for a metric for a particular day or a particular hour or a particular time grain, you can track how that data was generated over time. And then one of the things you can do as part of that is say, why is it not available? Is it because this step in the flow failed, because someone user logic changed, or because the Hadoop cluster went down for the day, or because the data just didn't arrive? And this has been super well received, right? Like, people no longer have to go and ask us. Right in their dashboards, they see a little link. They click on the link, and they get the complete graph of where in the processing pipeline they are and why their data is deleted. And it's saved us a bunch of time. So these were a couple of the innovations that we've built to sort of support us as we've sort of scaled across time, right? And I wanted to take this time to say, okay, these were things we built. These are the problems we solved. What did we learn? How are we sort of using our learnings to go and go to the next generation of innovation on this platform? So one of the first things we learned was that declarative definitions are good, right? People have known this for years in the database community, in BI, is the more things are declarative, the more your system can reason about them. And in general, if systems can reason about them, you can actually scale better than having humans reason about these things, because you can do optimizations, and once you do an optimization, it applies across the board. We've actually used it very effectively, right? Like, so let me give you an example. A lot of our tracking events come with things like headers, right? So there'll be a header that says, this is from so-and-so device, and there'll be some complex code that our tracking libraries generate for this device. And then we have UDFs that take that code and then generate, oh, this came from an iPad, this came from an Android so-and-so device, and so-and-so, and we like to do this. So this is what we call event dimensions, that says this event came from this device, right? And there's a UDF that does that mapping. And we have standard libraries that people write. Now, most people will remember to use the standard libraries. Once in a while, someone will forget, and someone will go and write in a pig code, they'll go write a case statement, or in Hive, they'll write a case statement that says, case when this string is like this, then it's so-and-so. And guess what? When that logic changes, that pig script starts breaking, right? And so we wanted to stop people from doing that and say, hey, if you're generating an event dimension for device, you should really use the standard UDF. If that logic is buried in something that's opaque to the system, you have no way of doing this. A human would have to go ensure that this dimension was actually generated by the right UDF. On the other hand, if it was declarative and you have the ability to introspect your code, you can say, oh, this is a dimension someone's generating. Let me look at the code to make sure that it actually came from the right UDF, right? And that would means that I could then warn you when you wrote your code saying, you made a mistake, do not check this thing in. And that allows you to scale significantly faster. So we've realized that declarative is good. We're trying to go more and more in this direction. And it also sort of fits in with our mission of saying, how many different ways can we generate metrics from one definition? A second thing that just ties into the example I just talked about is, you should build lots of validators and self-serve tools. At LinkedIn, we have a lot of people who want to onboard metrics, onboard logic, and they have wide variety of experience. Some of them are engineers and can write sophisticated pig code and Java code and so on. Others of them will understand what the problem that they're trying to solve, but their ability to write sophisticated code will be significantly less. And so the more validators and tools you can help them to do their jobs better, the more likely you're going to be able to scale. And this ties into my original comment of, in 2015, one of the things that allowed us to be successful with UMP was to centralize everything. And the way we did it was we asked humans to do this work. We asked humans to review the code. We asked humans to make sure that things were performing. But that puts a limit, right? Because as your number of metrics goes 4x in a year, there's no way humans can sit and review each one of these logics. And the idea is you start building tools to allow this. And once you've built that library of tools, you can actually decentralize this back. So you can push it back to the teams that were actually doing this and say, hey, you know your logic. You understand what metric you're trying to onboard. So please use this. Just use our library of tools to make sure that you're conforming with best practices. A third thing, and this was a huge learning for me personally after coming to LinkedIn, was how important culture was, right? Because we had this culture of our executives talking about the importance of data craftsmanship and data hygiene and people pushing it, a lot of people started onboarding things onto UMP. And this was the first time, and it wasn't necessarily a mandate, right? It was like, thou shalt do this. It was like, look, this is the right thing to do. And when enough people talk about it, and when executives talk about it, that changes the culture of the company. And that means that if you're building a platform to help people do the right thing, having a culture where this is encouraged and perceived as the right thing is a huge win. And the last thing is something that I'll spend a few minutes on, because I believe this is sort of a big portion of our learning, and I think is starting to influence a lot of work we're going to do. I'm going to talk a little bit about how what I call beyond Lambda and Kappa, and for those of you who are familiar with data processing, we've talked a lot about these architectures saying, hey, you know, there's Lambda, which is a combination of batch and stream. There's people talking about Kappa, which is stream-only architectures. So what we realized is that these are interesting concepts, and they're very powerful concepts, and they've helped us reason about things, but they're a single system concept, and which is why I made the comment that system designers think end-to-end, but when you're building a platform like metrics, for metrics or analytics or reporting, you have to think end-to-end to end, and I mostly wrote that because it just sounds cool. But let me talk about what I really mean by it, right? So data processing has, over the last 10 years, advanced a lot, right? Once Hadoop came on scene, everybody sort of adopted this whole theme of big data. Then we had Spark show up, we had Samza show up for doing real-time processing. The idea of Lambda processing, sort of having this stream pipeline to get, fast data, but that's inaccurate, and then sort of overwriting with the batch data, which is accurate, and then Kappa saying, no, you don't really need this, you can do all of it off of a streaming platform. For those of you who are familiar, Apache Beam has really done a lot to refine this thinking, like talk about why is it that there's this difference between Lambda and Kappa. How do you define logic how do you define logic once and have it run on a batch system and a stream system, and how you can actually do this efficiently, etc. And they've brought in all these beautiful ideas of having a unified programming model. How do you think about event time triggering, thinking about completeness checks, and all these other nice things. But I think there's a problem with this, right? So this is the standard Lambda architecture that everybody talks of. And so if you see on the left-hand side, you have all your incoming data and you have your processing layer. But that's only half the story. What that processing layer is it's taking all that data, munging it, and then sticking it into a serving layer. And then the serving layer is the one that people actually access, right? So all our discussions have been about that side of the platform, right? Not about the right side, not about the serving layer, not about the queries. And that's kind of odd because, end users see the results of the serving layer. They don't really care about how this data was computed. They actually see the serving layer. So why is this important, right? Let's remember how I said our metrics platform serves multiple applications. Let's look at two applications. We have our A/B testing framework, and then we have our anomaly detection framework, right? If the data for an R is not complete, you can't run anomaly detection because it's going to say, hey, you don't have enough page views for this R. Something's wrong. Go look at it. But nothing's gone wrong. It's just that the data for the R has not arrived. There's nothing fundamentally broken. You might be actually able to run the A/B test early. And the reason you can run the A/B test early is as long as the data that is late is divided equally between the control and the experiment, nothing breaks. You can still run your A/B test early, right? So these things the things that are on the right side of the ETL pipeline matter quite a bit, right? So understanding, someone might say, you know what, it's okay for me to see partial data. I understand that I only have seen 45 minutes of data for the last hour. Still show me that number, right? So the people on the right-hand side also need to reason about completeness and event time and all these other things, and we've excluded them from this conversation so far. And part of that has to do with the fact that when all of this started, we've been very heavily focused on pre-materialization as part of our analytics and reporting story. When a lot of this started, we had only key-value engines that you would serve these reports out of. When I first joined LinkedIn, one of our older reporting platforms used to use Voldemort, which is a key-value store. And so you had to cube everything, right? You had to generate, hey, for this country, in this time frame, this is how many people visited the site. And you had to pre-compute everything and shove it into Voldemort. But when we started using Pinot, which is a distributed OLAP engine, we didn't have to do that. Pinot would sort of compute those numbers on the fly. We had to do significantly less pre-computing. And what's happened, I think, over the last couple of years is that these serving engines have got better. Presto has the ability to serve many of these, even fairly sophisticated queries in relatively low latency fashion. If you're doing pure OLAP and cubes type queries, Pinot and Druid can do very, very sophisticated queries in milliseconds, not even seconds right at this point. So the question is, how much pre-materialization do you still need, right? And if you've been thinking about the left side of your pipeline, saying, hey, I need to do all of these things in the ETL side of it, then you're sort of limiting yourself because all of that things is about pre-materialization. So I want to leave you with a thought. We have ideas on how we're going to solve them, but I won't have time to discuss them. The thought I want to leave people with here is, especially those who are building reporting platforms, is you shouldn't be thinking about just batch and nearline, right? You're building a platform that spans not just the ETL, but also the serving side. So think about it holistically. Think about batch, think about nearline, think about your serving systems, think about how you're actually going to make your logic work across it. Materialization isn't your only solution. In fact, in many cases, I'd argue materialization is a problem. Shrikanth, who's a coworker, pointed out that premature materialization is like premature optimization, as Professor Knut said. Maybe it's the root of all evil. So with that, I'm done, and I'm happy to take questions.
Thank you, Shrikanth. Thank you very much. Okay, let's take a step forward, and we have got some questions for you. So, firstly, why did LinkedIn choose to build its own reporting app versus using one available on the market?
I think that's a great question. I think some of it has to do with that when companies like LinkedIn, at our scale, we use a lot of custom technology on sort of the left side of our pipelines, right? Which is we have a customized OLAP store, we have a customized document database, we built Kafka, we did all these other things. And that scale and that complexity that we have on the left side means that a lot of the conventional tools on the right-hand side, on the reporting side, don't just work out of the box. It's not that we don't use conventional reporting tools. You'll find pretty much every reporting tool that you can think of in use at LinkedIn. It's just that for the scale that we have to do mass reporting at, none of them work. So we use them sort of off on the side on our data marts, not on our larger systems.
Great. So, with multiple, I just want to make sure I'm asking the right question. With the multitude of metrics, do you have a structured approach on cleaning them up and dismiss any unused ones?
Yeah, so that's a great question, right? That's something we care a lot about. One of the things, when you build a central platform for computing metrics, and you're pushing it to the applications, you can start forcing your applications to say, hey, tell me what you're using and what you're not. And so because of that, we have significant visibility into not just, this is how much it costs to compute it, this is how much usage is getting. Should you really be using this thing? Is it time to deprecate it? Is it time to stop computing it? So yes. So we have a pretty structured approach, just not something I covered in that talk.
Okay, great. So you mentioned several hundreds of authors that build their own metrics on the platform. How do you scale onboarding, training, and quality assurance?
It's an excellent question. So we've taken this distributed approach. We started off with a centralized approach where there was a single team that was doing a lot of the code reviews, ensuring that things were up to spec. And last year, we realized this would break at some point. So to scale, what we did is we went out to all the customers. We started working with them. We picked champions in each of these teams, and we trained them to do exactly the same set of things that the centralized team did. And then we decentralized it and let those champions do the reviews. And they become, in effect, representatives of our team in those customer teams.
Right.
And that allows them to sort of keep all of these things going, and then we have a process for continuing to get champions and train them and mentor them and so on.
Okay, great. So our final question. Long posts became very popular on LinkedIn recently. How does that affect engagement?
That's a great question that I don't have an answer to. And even if I did, I don't know if I'd be allowed to talk about it. So I'm sorry, but I don't really have an answer for that one.
Okay. Well, thank you so much, Shrikanth. We have another picture. This is for you, if you want to take a step forward.
Oh.
This is for you.
Thank
Thank you
you.
so much for sharing your knowledge with us, and have a great conference.
Thank you.
Let's give him a hand clap.